In the silence between stars, there is no movement, only the memory of it. Light travels, but sound does not. And somewhere beyond the edge of mapped space, a long-range probe drifted in that silence, watching something fall forever. It had been positioned near the galactic core, not too close, not too far. Its task was simple. Observe the orbital decay of a neutron star caught in the well of a supermassive black hole. The system had been stable for centuries, its spin predictable, a textbook case of gravitational strangulation. The neutron star circled with solemn regularity, emitting pulses, tight, rhythmic, clock-like. But then the pulses began to arrive early. Not significantly, not urgently, just earlier than light should allow. At first, it looked like a calibration error. The probe's receiver might have desynced, but the onboard atomic clock was pristine, better than Earth's best metronomes. The discrepancy persisted across 3 full orbits, and by the 4th, it wasn't just timing, it was geometry, because the neutron star wasn't speeding up. Its position in space matched Newton's curve, but its emissions, its data, weren't obeying the same arc. Each pulse was behaving like it had traveled a shorter distance than the last, as if the information was taking a shortcut, as if the space between sender and receiver was folding inward, collapsing. Not in speed, but in topology. The team at the Deep Sky Array tried every conventional explanation. Relativistic lensing? Too weak. Doppler drift? Accounted for. Gravitational redshift? The math didn't match. And still, the pulses arrived earlier. Some theorized the black hole was altering the surrounding curvature so severely that paths of photons were being bent inward, like tight stitches across a torn fabric. But others began whispering something else, a suggestion that moved the explanation not outward, but inward. What if the black hole wasn't simply warping local space? What if it was altering the rules of the space itself? They revisited the telemetry archive from the start of the probe's mission. Years of logs, dozens of orbit cycles. The decay curve held steady until the final quarter. Then the drop-off curved upward. Not the star's position, not its motion, but the time signature of its radiation. Imagine a carousel spinning at constant speed. You watch from a fixed point. Each horse passes predictably. But suddenly, the light from the horses begins to reach your eyes before it logically should, despite no change in the spin. That's what they saw, and it meant only one thing. The carousel wasn't changing speed. The space between the horses and the observer was changing shape. It was then someone suggested a phrase from the archives of theoretical physics: topological lensing. A term that lived mostly in speculative papers. The idea that not only can space be warped, but connectivity can be redefined. That a loop of space, like an orbit, might intersect itself across dimension rather than across time. In this view, the neutron star wasn't decaying inwards. It was slipping along a folded edge of space-time. Each orbit wasn't just smaller. It was closer to a membrane we didn't know existed. And if that were true, then light wasn't speeding up. It was cheating, passing through a shortcut that shouldn't exist. Somewhere near the event horizon, the space around the neutron star was behaving as if it were a boundary between layers, not just a slope of gravity. The black hole wasn't pulling the star inward. It was folding reality around it. A secondary probe was dispatched, not to observe motion, but to map gravitational symmetry. Its data returned something chilling. Not asymmetry, not turbulence, but a perfect echo of the primary path. From 2 places at once, the orbit seemed to reflect itself, not as a duplicate, but as a layered projection, like the same particle being measured twice, in 2 slightly different universes. That was when the idea of dimensional tunneling became more than a fringe theory. Because if the pulses were arriving early, If the star's emissions were taking shorter routes, if orbital signatures appeared mirrored, then it wasn't just gravity behaving strangely. It was context. And if black holes could fold context, then they might not be prisons of light. They might be portals, not by tearing holes in the universe, but by pinching its layers close enough that the laws of distance and cause no longer held. Of course, no one said gateway out loud. Not yet. The term carried too much myth, too much science fiction, too much human hope. But in the dark corners of the lab, scientists wrote new simulation code, models that accepted the presence of additional dimensions, not curled up strings, but broad, folded volumes. And in those simulations, the neutron star's behavior made perfect sense. It wasn't losing speed. It was entering a space where the concept of speed bent inward, where time and motion looped into something else. Back in space, the neutron star completed another lap. This time, its signal arrived before the orbit technically completed. Impossible, except not anymore. The instruments didn't alarm. They merely confirmed. The pulse had arrived. Not faster, not brighter, just sooner than it should have been allowed to exist. The smallest particles don't obey the same rules as stars. In the realm of the quantum, distance is negotiable. Information can be shared across vast spans without traversing them. Entanglement, they call it. A state where two particles mirror each other, no matter how far apart, like a coin tossed in two places that always lands the same way. So when the team proposed testing entanglement near the event horizon of a black hole, they weren't chasing science fiction. They were looking for limits. The design was elegant. One photon pair, generated in perfect symmetry, was split. One particle remained on Earth, sealed in isolation. The other was sent aboard a probe to skim the gravitational edge of the black hole observed in Part 1. The mission: monitor coherence. See how long the link between the two particles held as one approached the edge of no return. It wasn't meant to be flashy. It was meant to be final. Everyone assumed that once the probe crossed the threshold, decoherence would follow. The link would break. The particle aboard the probe would vanish, or at least its effects would stop registering. But that's not what happened. As the probe drifted closer to the event horizon, the Earth-side particle behaved as expected, spiking with mirrored polarization shifts, maintaining the rhythm. But after the probe crossed into what should have been the point of no signal return, the Earth particle didn't stop reacting. It kept twitching. It kept shifting. It kept answering, but the probe sent no data back. The channel was silent. No packets, no telemetry, no particle scan. And yet, somehow, the Earth-bound particle continued responding, but not to its twin. The physicists were unsettled. Quantum behavior is notoriously fragile. Entanglement breaks easily, under heat, interference, or even time. But here, inside a sealed chamber half a galaxy away from the black hole, a lone particle was behaving as if something was still speaking to it. Something that felt familiar, but no longer matched the signature of its original pair. As if it had remained linked to something that continued to exist, but not in this universe. Theories emerged, shaky at first, then bold. Some blamed latent electromagnetic contamination. Others posited random alignment coincidence. But when the signal persisted for 11 days straight, with non-random patterns, the skeptics quieted. And then someone proposed what no one wanted to say out loud. What if the other particle didn't decohere? What if it transitioned? Enter the idea of bulk space leakage. According to brain cosmology, our universe may be a 4D membrane, floating within a higher dimensional bulk. We don't see these extra dimensions directly, but gravity might slip between them. That's why it's weaker than other forces. And black holes? They may be the only places where the brain stretches thin. Thin enough for something to fall through. Not die, not compress into a singularity, but slide sideways. Not into darkness, into elsewhere. The entangled particle aboard the probe may not have broken. It may have crossed into another brain, and its Earth twin, still shackled by symmetry, remained linked, not to the original, but to its displaced echo, a ripple, faint and confused, still reaching backward from beyond the event horizon. Not as a message, but as a pull. They tried new entanglements, new probes, but none survived long enough to confirm the pattern. Only the first, by fluke or fate, had drifted in just right. A tangent skimming the curve of the horizon. A fall that wasn't a fall. An exit masquerading as a boundary. Eventually, someone posed a question. If particles can leak, what about data? Because the probe hadn't been destroyed. It had ceased to register. But its systems, on Earth, continued flickering in response. Diagnostic uplinks pinged it out of habit, but never got replies. And yet, computational ghosting persisted. Not full transmissions, just patterns in local noise. Pulse echoes in onboard firmware. Static that rhymed with the probe's original clock cycles. The software team dubbed it non-local persistence. It meant the data didn't return, because it didn't stop. It wasn't gone. It had simply changed hands. By the end of the month, a new protocol was drafted. No longer did they treat the event horizon as a termination zone. It became a handoff point, the threshold between recorded physics and the rest of the possible. And while nothing was retrieved, something was still reacting, still aligning, still present, but no longer here. The final entry in the lab's mission log was unsigned. A single sentence, left at the end of the particle coherence file. We sent a question into the dark. It didn't answer. It simply continued. Silence has texture in space. It isn't pure. It's layered. A faint hiss of background microwave radiation hums from every corner of the sky. Relic heat from the Big Bang, soaked into the bones of the universe. It's called the CMB, the cosmic microwave background. For decades, it's been our most consistent map. A kind of fossil light, older than stars. But one satellite, meant only to listen, found something inside that silence that didn't belong. A pulse, then another, then a rhythm that felt like memory, but wasn't ours. The satellite was positioned in polar orbit around the observation zone featured in parts 1 and 2. Its task was to chart temperature anomalies in CMB missions near the black hole's event horizon. Everything began as expected. Subtle shifts, predictable interference. Gravity warps light, even ancient light. That part made sense. What didn't was the echo. A faint, structured signal repeated at precise intervals. Not loud enough to register as foreground, but not random. Never random. When converted into waveforms, the pulses revealed modulation. A gentle rise and fall in microkelvin radiation that matched known early universe expansion metrics. Except one detail. The frequency slope was wrong. Not broken, not noisy, just different. As if the universe it came from had expanded at a different rate. The lead analyst ran the pattern through a simulation. The result? A consistent cosmological model. Only it wasn't ours. In this version, the ratio of dark energy to baryonic matter was slightly higher. The curvature of space, slightly flatter. The Planck constant, fractionally off. Tiny differences, but enough to rewrite everything. That's when someone asked the question, what if this isn't our past? Because the CMB is a historical document. An image of what the universe looked like 13.8 billion years ago. But this echo didn't fit our history. It fit a history, just not here. The team began overlaying the echo against our own background map. The points of divergence formed a distinct, repeating arc, a half-ring that pulsed every 9.4 hours. That's when it became clear. The pulse wasn't moving through time. It was drifting along dimension. Not forward, not backward, across. One physicist suggested the term cosmic bleed-through, a phenomenon where gravitational topology near a black hole becomes so sharply pinched that CMB imprints from other brains leak into ours. Imagine pressing your hand against a frosted pane of glass. You can't see clearly, but you can feel something just on the other side. That's what the echo was. A handprint, a gesture, not meant for us, but somehow received. The radiation profile was rerun, and it revealed something else. Embedded in the echo, between its frequency curves, were tiny oscillations consistent with hydrogen line emissions. Not our hydrogen, slightly skewed. The fingerprint of an element born in a universe with different nuclear ratios. Which meant the black hole wasn't just showing us another history. It was whispering another chemistry. The satellite was reprogrammed to focus entirely on the anomaly. In doing so, it lost 2 of its backup telemetry arrays. No overheating, no collision, just blank sectors in memory. Like something had overwritten the data buffer. The only remaining files were the waveform logs, and in them, something changed. The echo wasn't just bouncing, it was responding. The pulse patterns began shifting in time with the satellite's orbital position. Each time it swung closest to the black hole, the pulses came faster, sharper, not louder, but more ordered, as if something, on the other side, was watching the angle and adjusting, not with language, not with code, but with cosmic light. It wasn't a message. It was a mirror, not reflecting our universe, but showing us that others exist, and that they see us too. The lab concluded its report with a single line under the origin hypothesis field. Emission source location indeterminate. However, profile implies emission through singularity, not from within it. It was the cleanest way they could say what no one wanted to believe. The black hole may not be a hole at all. It may be a bridge, and something somewhere might be standing at the opposite edge, looking across. The final transmission came at 2:41 Universal Time Coordinated. There was no alarm, no rupture, no error log. The probe had been maintaining a soft arc near the gravitational shell of the black hole, hovering just beyond the theoretical event horizon, following a curved trajectory defined by light-bending equations and extreme relativistic drift. Frame by frame, it was stable, and then, one frame it existed, the next it did not. No blur, no shockwave, just a flicker, an edit in the film of reality, as if something had cut a single object out of the scene, clean, surgical, and silent. Recovery teams searched for debris. They found none. No particulate plume, no loss in background radiation, no gravitational signature spike, no energy spike at all. The satellite monitoring the region sent back a flatline report. But back on Earth, a systems technician noticed something impossible. The probe's quantum channel, the signal used for its entanglement-based data logging, was still active. Not transmitting content, just persisting. Normally, once a system decoheres, either from destruction or quantum drift, the entanglement signature collapses. It becomes noise, irretrievable. But this signature didn't die. It shifted, beyond known encoding ranges, beyond quantum parity locks, into a spectrum no instrument could interpret. It was alive, in a technical sense, a signal with no readable format. Still pulsing, still emitting, still there, but now without an origin point. The team described it as a frequency orphan, a carrier wave with no source. And yet, one that matched, identically, the probe's last logged identity token, like a voice still humming after its speaker had been erased. Not erased by heat, or force, or distance, but by transition. A second probe was prepped for launch. Redundant shielding, new telemetry buffers, passive mode only. It never left the cradle, because in the week leading up to its deployment, something else happened. The orphan signal began modulating again, but not with content, with rhythm. Tiny fluctuations in phase, amplitude, pulse width. At first, it looked random. Then, in Fourier space, it mapped into a waveform, a slowly repeating envelope. Not a message, not code, but something else, a pattern of retention. It wasn't saying anything. It was holding something, as if the probe, wherever it had gone, was still running its systems, still trying to connect, but across a membrane too thin to reach through and too thick to shatter. Some likened it to the hum of a submarine radio, still echoing through pressure layers long after contact had been lost. Others compared it to a heartbeat heard through glass. But one theoretical physicist proposed something else, a phrase that haunted the lab's quietest moments. What if it's still sending data, but the universe receiving it is not ours anymore? The project was paused indefinitely. Officially, they cited budgetary caution. Unofficially, they were afraid, not of what the probe found, but of what it didn't. No signal, no return, no answer, only continuation, only a ripple, only a ghostly persistence in a form we weren't meant to decode. Because black holes were supposed to be endpoints, silent funnels of gravity, places where time bends and matter dies. But now, sitting with a signal that refused to end, scientists had to confront a quieter, stranger truth. What if a black hole is not death, but handoff? A gate not marked by fire, but by silence. By a one-way transit, tidy and deliberate, as if the laws of our universe contained a clause. A redirection, not destruction. A place where information is withdrawn, but not lost. Cataloged, transferred, filed somewhere else. The last memo logged in the project archive bore no header. It was anonymous, a single line, left in the server console at 3:02, time-stamped 3 days after the probe vanished. Whatever's on the other side, it knows not to speak, because that was the strangest part. The black hole didn't answer. It never did. Not when the neutron star's orbit folded. Not when the echo whispered from another set of constants. Not when the signal slipped past coherence. Not once. It simply accepted. And what came out, if anything ever did, never said a word. The gate did not scream. It did not flare. It did not shimmer. It just closed. Without sound. Without heat. Without goodbye.